All right, this is a quick video for the midterm study guide. As you all know, I told you can skip number 11 and number 33. I just wanted to explain why we're skipping 33. If you have 15 over the square root of 7, according to what we've been doing in class, this cannot be further simplified. I told you that you need to bring everything you can out of the square root. So normally you factor the radicand, the thing inside the square root. In this case, it's 7. But 7 is prime. It can only factor to 7 times 1 or 1 times 7. And we're not going to be able to square root anything else out of the radical. A couple of people have brought up an extra step that I have not taught in this class, but you may have seen in a previous class, or you definitely will see when you take future math classes. And that step is called rationalizing the denominator. All right, and where this word comes from, rationalize, means to make rational. Remember that a rational number is something that can be written in the form P over Q, where P and Q are both integers. So here's some examples of rational numbers. Like 5 is a rational number because even though it's not written as P over Q, it can be. 5 can be written as 5 over 1, right? And 5 and 1 are both integers. Really, it could be written as 10 over 2, and 10 and 2 are both integers, right? And there's other ways to write 5 that look like rational numbers, but you only need to be able to write it one way. Another example of a rational number might be 1.75. Again, that doesn't look like P over Q, but we could write it that way. It's 7/4. And again, you can find equivalent fractions. That could be 14/8 or so on. What's kind of tricky, though, is that I could even take something like 5, which we know is rational because it can be written as a fraction of integers. And I could actually write it as a fraction of non-integers. I could say 5 is the same as 5 root 7 over 1 root 7, couldn't I? Because that's just 1. We end up getting 5. The problem is 5 root 7, that's not an integer, and neither is 1 times the root 7. So just because something is written with the square roots in it, or written with things that aren't integers or even rational numbers in them, doesn't mean they can't be written as a rational number. So I'm not actually going to prove this here, but 15 over root 7 is not written as P over Q. And no matter what kind of math gymnastics, any kind of multiplication, division, manipulation you want to try, you will never be able to write 15 over root 7 as a fraction or a ratio of integers. So we have to deal with what's the next best thing. And so the most widely accepted way to write these kind of numbers is to make sure that at least the denominator is rational, even if the numerator isn't. And so, again, for my class, this is a perfectly acceptable answer. But as you get into future math classes, you should know that it's more proper to rationalize the denominator, at least make the denominator an integer, or at least a rational number. The way we're going to do that is we have to rely on 2 facts. First, hopefully you already know this fact. I sincerely hope you would agree with me that if you multiply something by 1, it doesn't change that something. Anything times 1 is itself, right? So if I take 15 over root 7 and multiply by 1, I am going to get something equivalent to 15 over root 7. It just might look a little different. And the reason it's going to look different is because I'm going to pick a very specific version of 1. I'm going to choose the square root of 7 divided by the square root of 7. Hopefully you also know that anything divided by itself is 1, right? The square root of 7 divided by the square root of 7 is 1. All right, so I'm going to take our fraction we were given. We're going to multiply across like we do with fractions. And we'll get 15 times the square root of 7 in the numerator. And in the denominator, the square root of 7 times the square root of 7, that's the square root of 49. But this is where rationalizing the denominator comes into play. Now we know what that is. We know what the square root of 49 is. It's just 7. So we have 15 root 7 in the numerator. And now we just have 7. There's no square root anymore. We've evaluated the square root of 49. We know that it's 7, so we replace it with 7. And that would be what in most math classes is considered the more appropriate answer, the more proper answer. Again, for my class, you can totally leave it like that. You do not have to rationalize the denominator. But if you see an answer key and it shows this instead of that, now you know why.